So here we're going to learn about how to add and subtract fractions. I've prepared a question here that says 1/2 plus 2 3/4 minus 5/3. I've used the three types of fractions that we've seen so far. A simple fraction where the numerator and the denominator are, as you see over here, 1/2, 1, the numerator, smaller than the denominator 2. Then over here, 2 3/4, that's a mixed fraction. There's 2, a whole number, and 3/4, the fraction part. Minus 5/3, and here's an improper fraction because the numerator here is bigger than the denominator. 5 is bigger than 3. Before I start adding and subtracting, I should tell you that there are a few ways to do this, but the way I prefer is to convert all fractions into non-mixed fractions. So the 2 3/4 will have to be converted into an improper fraction before I can do anything. I'll recopy the 1/2 over here, 1/2 plus, and now to convert 2 3/4 into a improper fraction, what I do is I take the 2 and I multiply it to the 4, so it's 2 times 4, and then I add 3. So what I get is 2 times 4 is 8 plus 3, 11 quarters. 11 out of 4, the denominator remains 4, minus 5/3, which stays the same. Once I've converted everything into non-mixed fractions, in this case only the middle fraction needed to be converted, the next thing I need to do is get a common denominator. I can get a common denominator either by remembering my multiplication table and looking for the smallest common multiple between 2, 4, and 3, which I know is 12. Or, not knowing that, what I can do is create a table of multiples. So if I'm looking for the lowest common multiple for my denominator, my lowest common denominator is going to be the lowest common multiple between 2, 4, and 3. So let's make a table for 2, 4, and 3. Table of multiples, and I start counting by 2's here. So 2, 4, 6, 8, 10, 12, 14, 16, etc. For 4's, it's 4, 8, 12, 16, 20, etc. And for 3, it's 3, 6, 9, 12, 15, 18, etc. I should notice right away that the lowest common multiple here is 12. And so in that case, I'm going to use 12 as my denominator, as my common denominator. So I'm going to rewrite this as something over 12 plus something over 12 minus something over 12. The top number, the numerator, we're going to get that by asking ourselves, 2 times what gives me 12? Well, that's 2 times 6. But if I multiply the denominator by 6, I must multiply the numerator by 6. Whatever I do to the bottom, I have to do to the top. So 1 times 6 is 6. So I get 6 out of 12. That's the same as 1/2. Plus, to get 12 here, I need to do 4 times 3. But if I do 4 times 3, then I do 11 times 3, and that gives me 33 over 12, and then minus 5 over 3 to convert that. To have a denominator of 12, I do 3 times 4, and then I do 5 times 4, so that's minus 20 over 12. Now if I have 6 12s and 33 12s, and I lose 20 12s, then I'm going to end up with how many 12s? Well, 6 plus 33, that's 39. Take away 20, that's 19. 19 12s is what's left over. Can we reduce this? Well, is there a common factor between 19 and 12? It turns out no, because 19 is a prime number, and the only thing that divides 19 is 1 and 19, and neither of those go into 12 except for the number 1, but we don't need that. So let's convert this into a mixed fraction just for fun at the end. What we'll do is we'll take 19 and we divide that by 12. How many times does 12 go into 19? If I say twice, that's 24. That's too much, so let's go down 1. And we'll say that 12 goes into 19 once. 1 times 12 is 12. Subtract. What's left is 7. So essentially what I'm saying is I can make one group of 12 with 7 pieces out of 12 left over if I divide 19 by 12. So my final answer in mixed fraction form is 1 7/12 after adding and subtracting these three fractions together.